Hello, Professor. This is my topic 6, task 3, assignment. I share my screen to show my codes. And this task is about the variance comparison analysis. And the data set used is about types of rooms in NYC neighborhood of 2 or more populations with variances to compare from a reliable source. The data set was loaded to the Jupyter notebook and the hypothesis test for variance comparison was done. The problem stated here is relating to analyzing and comparing variances in the prices variable across different groups or categories. The data set was obtained from Airbnb listing, which includes information on various factors such as neighborhood groups, room types, and prices. The research question focused on understanding whether the variances in prices differ significantly across different neighborhood groups and rooms in New York City. The appropriate statistical test used to address the research question is Levine's test for variance comparison. In this case, it has been applied separately for different neighborhood groups, which were Brooklyn, Manhattan, Queens, Staten Island, and Bronx, as well as the different room types, such as private rooms, entire home or apartment, and share rooms. The assumption of this test is that Levine's test has certain assumptions, such as independence, normality, and homogeneity of variances. For independence, the assumption is the observations within each group are independent of each other. The consequences of violation is that if observations are not independent, it may lead to inflated type 1 error rates and incorrectly rejecting the null hypothesis. The possible remedies are to ensure the observations within each group are independent. For normality, the assumption is the residuals should follow a normal distribution. The consequence of violation is the departure from normality could affect the validity of the test, especially in small sample sizes. And the possible remedies are that if sample sizes are large, Levine's test is robust to violations of normality. For smaller sample sizes, consider using alternative tests such as the Brown-Forsyth test or the Welch test, which are less sensitive to departures from normality. For homogeneity of variances, the assumption is that the variances of the group being compared are equal. The consequences of violation are if variances are not equal, Levine's test may become less powerful and result in inaccurate conclusions. The possible remedies are for the violations of homogeneity of variances, consider using alternative tests, like the Welch test, which are designed to handle unequal variances. And now I show the code that I did here. This is the data set and the hypothesis test that was performed, the Levine's test here between the different neighborhoods and the room types and homes and apartment. And the Levine test for variance comparison in Brooklyn gives these results and shows that for Brooklyn, the variances are significantly different. For Manhattan, it's the same. Queens, it's the same. Staten Island, it is not significantly different. And for the Bronx, variances are significantly different. For private rooms, it is significantly different. Entire homes and apartments, the variances are significantly different. And for the Levine test for shared rooms, they are significantly different. And the results I got here is, I wrote these here to show that for example, for Brooklyn, the null hypothesis was rejected. And the insights here, this is the Python test, the Python tool to assist with the interpretation and the visualization. These are the results, and this is the visualization of the results. And with this, developing the Python tool for interpreting statistical test results and creating visualization can be highly supportive. And using popular libraries like SciPy, Matplotlib, and Seaborn are useful. NumPy is used for numerical operations and creating arrays. SciPy is used to provide statistical function, and matplotlib.pyplot allows for creating visualizations like plots, while Seaborn enhances the style and aesthetics of the plot. Based on the provided results, for most categories, which are Brooklyn, Manhattan, Bronx, Queens, private rooms, entire homes and apartments, and shared rooms, the p-values are very small, leading to the rejection of the null hypothesis. This indicates that the variances in prices are significantly different among these groups or categories. However, for Staten Island, the p-value is greater than the chosen alpha, which is 0.05, suggesting a failure to reject the null hypothesis. Therefore, there is not sufficient evidence to conclude that the variances in prices are significantly different in Staten Island. And overall, this analysis provides insight into the variability of prices across different neighborhood groups and room types, helping to identify groups where the variances in prices are notably distinct. That is my presentation for task 3. Thank you.